Nice.
Thanks, Sarah. It's Monday, Sam. No.
Okay. So, friends, there are a few of you that still need to finish something with me, and I'm being sarcastic, but this is a lot. By Friday, please. By Friday.
Oh, that's a lot of time.
I think it's generous, but you know what? Someone's gonna be like, "That's not fair."
I have a busy week, Sarah.
Hey, me too. So I figured Friday would be okay.
Nice to
So we had trig B. Is that right?
Yeah.
Trig B.
The circular thing.
Okay. All right. What kind of questions did we come across on the trig thing?
12 and 6.
What?
Anything from 2 to 19.
2 to 19? Okay, give me one.
15.
15 sounds good. All right, so problem number 15, and I'm going to do it two ways for you. So negative 45, just so you know, that's this angle. That's negative 45 degrees because I went clockwise. So if I wanted to give the smallest positive angle, that's positive. So I'm going to come around this way. So that's going to give me 315 degrees. 315 degrees is the same location on the unit circle as negative 45.
So you basically did 360 minus 45.
Yep. Okay. Now, the difference between those with the coterminal and the reference angle, let me show you this as an addendum, and this I think will work a little bit better for you. All right, so be patient with me. I haven't done this in a... That is here. Okay, XY axis, unit circle on top. Still with me? Okay, so we talked about last time that we had certain angles in there. So, what did I do?
Let's look at the X-axis.
Okay, so this looks like a whole fancy thing that you would have drawn and put on the fridge for mom when you came home from third grade, right? All this really is, though, is, so the green is the 30, 60, 90. Okay, so no matter where the green is, so here's the right angle, here's the right angle, here's the right angle, here's the right angle. So please note the 30-degree angle is coming off the x-axis. The red is the 45, 45, 90. Okay, so the red is the 45, 90, and again, it's coming off the x-axis where we make our triangle. And then the purple, if I could spell, not purple, is the 30, 60, 90 where you're using the 60 degree as the angle. And again, these are all right triangles. Now, there's an infinite amount of right triangles that exist within here, but there's the two special right triangles, one that you can have the two acute angles be the 30 or the 60, and the 45, 45, 90 is one of them. So this is all we're doing. So on the one that says give the smallest possible angle between 0 and 360, I guess it's this. I guess that's what they're doing. Something like that. That means I'm coming around the angle this way and figuring out where it falls, where I started here. Okay? If I go to determine the reference angle for each, the reference angle is what angle is coming off the x-axis. Oops, that went too far. Oh, man. What came off the x-axis? And then let's see if I can draw that a little better. Okay, so really, on 36 or 44, all you're doing is you're telling me if it's a 30, a 60, or a 30, 60, or 45. Okay, it's coming off the x-axis. So one is, hey, where did my angle find? So that was, what is the smallest positive angle, the coterminal angles. So it's from 0 to 360. So you're starting here and you're saying, where did it end around here? And then the other one is, hey, what angle is coming off the x-axis for any of those? And the nice thing is the 150, 240, 210, 225, 300, 315, 120, 330, and 135 are all either a 30, 60, or a 45-degree angle.
Oh, so you can do like trigonometry.
That's exactly right. So if I have right triangles inside, so there's things that I have to recognize. So if I knew this, if this is 1, 2, square root of 3, then this point right here, because it's the 30, I come over and it's at root 3 comma 1. And if I came over here, it's still a 30-degree angle, but I'm going to use negative root 3 comma 1. Why is it negative? Well, I went to the quadrant 2. And then this is, both of them are negative. So I get negative root 3, negative 1. And this one down here, I have root 3, negative 1. And then as I progress around it, think about the 45, 45, 90, where this is 1, 1, root 2. So this point right here is the point 1, comma 1. This point right here is the point negative 1, comma 1. This point here is the point negative 1, comma negative 1. And this point here is the point 1, negative 1. And then if I go down to the 60, purple. So if I go down to the 60, 1, 2, root 3. So if I go to the 60, I went right 1. And then the last part of this is the point 1, 0. That's the point 0, 1. That's the point negative 1, 0. That's the point 0, negative 1. So you can identify exact points as you go around the unit circle with the right triangles embedded in there. Okay? Now turning from this pretty art project into a whole lot of gibberish. Good. What other questions you come across on the homework? 6? 1,200 degrees?
Yeah.
All right. Do you agree this goes around the unit circle a couple of times?
Yes.
I'd say at least 720. If you have a calculator, get it out so I know I'm doing my math right. Subtract. That's what, 2, 1. That 420, baby. And subtract another 360 because so that's a 60-degree angle. Okay. So you count how many times it goes around the unit circle, and I thought it went around twice, but it went around 1080 actually. So went around 3 times. So what 1200 means is this. Here's your 60-degree angle, right? The 1200 just did this. 1, 2, 3, back to that. So it just spins. And the reason I show it as a bigger circle is so you can see it spinning on top. You know, the circle doesn't have to get larger as it moves, goes around. Other questions? $35?
It's the one with words.
What do you know about the signs of the coordinates? Okay. So 35. Here's our XY axis. Here's our unit circle. Bless you. This is quadrant 1, 2, 3, and 4. Any point here is positive, positive, and the negative, positive, negative, negative, and positive, negative. So the XY values flip-flop, either to be positive, negative, one of each, or both. Anything else? 19? Number 19. Negative 1,000. Okay? So this is an angle that's actually going this way. So there's negative 360, negative 720, and it's going to keep going a little bit more. Okay?
So 720 minus 1,000.
Yeah, let's figure out what that is. 8, is that 280? Okay, so we're at negative 280, so this is going to keep coming. So that's negative 90, negative 180, negative 270, so it's like right here. So what is this angle here? Well, that was 10 degrees more, so this has to be 80 degrees because the whole quadrant is 90 degrees.
Nice.
Anything else?
So would 10 just be also 80 degrees? Going the opposite.
10 goes the other, so this is what 10's doing. 1, 2, and then 270. Two's like down here. So it's down there. So how far is this angle? This angle right here. That's 310. Or 300. Sorry. 10. Yeah, 300 degrees. Anything else? Make sure your name's on it. Pass it on up, please. What did I do wrong this time? You guys are gibbering a lot. We don't have a cupcake here too, so.
What time are you getting tomorrow?
We're 6:45. What time do you want? And I have a meeting at 7:30. Does that help?
Yeah.
Any more homework that I'm missing? Oh shoot! You know I gotta pick on you already.
It's hard to acclimate to the week after a long weekend. It's not long, but like, it's the
Alright.
you know.
So, not real tough thing today. The one thing just we all want to realize is the radian measure. It's it's like the difference between Celsius and Fahrenheit in chemistry, or absolute value in Fahrenheit, or absolute value in Celsius. It's just a different way to measure. That's all it is. It's a different mechanism to measure. So 1 degree is not equal to 1 radian. There's a relationship, but they do tell us that all the way around the circle is 2 radians. So that's the main one. Guys are talking too much back there. Subtle hint, red. Alright, so all the way around a circle is 2 radians. So halfway around a circle would be 1 radian, or pi radians. Okay? So let's figure out this. So if that's 0 radians and that's pi radians, then this is also 2 pi radians, because all the way around the circle, 360. So if I go from here to here, and from here to here is pi radians, how far do you think from here to here would be? Yeah, pi over 2. Okay, half a radian, half pi. How much would I go? I'm going to go 90 more here. So what do you think this one is down here? 3 pi over 2. Basically, I'm adding pi over 2 to pi. So that becomes 2 pi over 2 plus pi over 2 is 3 pi over 2. And then we have to start thinking, okay, let's look at the red first. We'll deal with the 45-degree angle. So between 0 and pi halves, I'm halfway there. So what's halfway between 0 and pi halves? Pi over 4. Okay? So again, you're adding another unit here. So if I come from here, I want a quarter, half, 3/4. So 3 pi over 4 is this one. Then if I come down this one, I've gone a little bit further. I went pi fourths, so this becomes 5 pi over 4. And then on this one right here becomes 7 pi over 4. I think I have that right. All right, let's verify I've got this. Let's verify I got this. So I can assure you I have this right, and I can assure you this is right. So let's go through the math real quick to make sure we're good. I can wait. I'm competing with other voices, and they're not the ones in my noggin anymore. So how do I go from here to here? I've gone 45 degrees more. So you have to realize that 45 degrees is equal to pi over 4. So if I went from pi over 2 and I added another pi over 4, that's going to be 4 pi, or wait, excuse me, 2 pi over 4 plus pi over 4. So that's 2 pi plus 1 pi is 3 pi. And then if I get down to here, that's pi. And if I want to add pi over 4 to it, because that's 45 degrees, then I'm going to have 4 over 4 pi. So 4 plus 1 is 5. And then if I wanted to get to here, I want to go from 3 pi over 2. And I'm going to go 45 more degrees, or pi fourths more. So I'm going to make that 6 over 4. So that's 7 pi over 4. So all it's doing is you're just adding fractions and keeping it in units of pi. Okay? Yeah.
Is that a 6?
Yeah, I changed 3 pi over 2 to 6 pi over 4 to get a common denominator. Rather than do my fancy way of adding fractions, I didn't want to deal with pi's that way. Okay. Where do I want to go next? 30-degree angle. Let's do this 30. So that was a 30-degree angle. 30-degree angle is 45 is already the red. 30-degree now. So 30-degree, how do I think we should get there? How many 30s are from here to 180? How many times do I have to add 30 to itself to get to 180? 6. So that's got to be pi over 6. Okay? So 30-degree angle is pi over 6. So then if I wanted to figure out this one here, I'm going to back up from pi. So I'm going to go pi minus pi over 6. So that's 6 over 6 pi. So that's going to give me 5 pi over 6. This 30-degree angle right here, I'm going to add pi and pi over 6 to each other. So that's going to give me 7 pi over 6. And then this 30-degree angle here, and again, we're referencing up there, I'm going to go 2 pi minus pi over 6. So that's 12 pi over 6 as a common denominator minus pi over 6. That's going to give me 11 pi over 6. And then I have a 60-degree angle is my last one I want to deal with. The 60 degree is going to be pi over 3. And so if I were to add pi over, or no, I can't do that. If I were to go pi from here and back up 60 degrees minus pi over 3, that's 3 over 3 pi. So that's 2 pi over 3. This is another 60-degree angle, so I'm going to go pi plus pi over 3. So that's 3 over 3, so that's 4 pi over 3. And then that one, I'm backing that off, so I'm going to go 2 pi minus pi over 3. So that's 6 pi over 3 minus pi over 3. So that's going to give me 5 pi over 3 right there.
Hey, Mr. Stark, what's the black one?
That's the 60-degree angle. 60 degree is pi over 3. Because the 30, 60, 90, I can use the acute angle of the 30 and the acute angle of the 60. And that's what comes along with these. Okay, so degrees are what I would love to keep everything in. Unfortunately, we fight this battle of we should do it in radians versus degrees and degrees versus radians. I haven't heard a genius thing other than you see it both ways. And it's really sick and demented that they give you a test and it'll say, hey, do this problem. And you're like, hey, 20 degrees. The sine of 20 degrees is this. And then the next, and you're expected to give your answer in degrees. And then the next problem is, hey, you have the sine of pi thirds. And then you have to make sure you give it in radians. So you're recognizing that when you have pi as inside of your angle, you're talking about a radian unit. And again, it's just an increment as you go around. And I got to think of a better way to present this other than that's it. There is a conversion factor. So let me get to my conversion real quick. It's not there. Move off that. So if I want to go from a degree to a radian measure, what you're going to do is you take whatever your angle theta is in degrees and you multiply it by pi over 180. Okay? And that will give you your answer in radians. So if we had done the 90 degrees times pi over 180, what's 90 over 180? Half. So that gave me the pi over 2. Is that what we said 90 degrees is equal to before? So what about if I had, like, say, 40 degrees? I'm going to multiply that by pi over 180. Well, reduce where you can, so that's going to become 4 pi over 18, and that's going to become 2 pi over 9. So this is beneficial for you to know to go from degrees to radians. What do you think it is to go from radians to degrees?
Opposite.
Yeah, multiply by 180 over pi. If you want the pi's to cancel out, that's the best way to remember that. So if I want to go this way, I'll multiply my radian amount, so my angle times 180 over pi. And And the nice thing is then you start getting the things to start canceling out. So if I were to take, say, this right here, and say, okay, pi over 2, I know it was 90 degrees. If I multiply that by 180 over pi, the pi's cancel, and I get 180 over 2, which is 90. Okay, so this allows you to go backwards from radian to degree, the other one degree to radian. I guess the best way to remember that is the pi is on the bottom if you have pi as part of your answer that you're converting. Make sense? So it's the simple relationship right there. That was bonus material. We weren't supposed to teach that today, but I did. All right. So remember quadrantal angles. That is, quadrant 1 is bordered with 0 and pi halves. Quadrant 2 is bordered with pi halves and pi. Quadrant 3 is bordered. Okay, so we already have that all done. So 0 and 2 pi. That's pi. That's pi over 2. And then 3 pi over 2. And that's just saying, hey, this is quadrant 1, quadrant 2, quadrant 3, quadrant 4. We talked about this the other day, saying that was left-handed behavior because Descartes, who made it, or Descartes, who it looks like, was a left-handed mathematician. So he got to make up the rules. Just imagine back in the day, no internet, no TV, no Tom Brady, no one cheated. I mean, I'm just kidding.
All you have is math. Sounds lame.
Yeah, I was just glad we had good food. I thought the commercials sucked too. So.
Yeah, they weren't funny.
All right.
Disappointment of game.
All right. Determine what quadrant on the axis lies. So remember, 1, 2, 3, 4, and then 0 and 2 pi, pi halves, pi, 3 pi over 2. All right, where's pi fourths? Quadrant 1, 2, 3, 4. 1. Where is 2/3 pi? It's got to be in quadrant 2. Where is 11 pi over 6? So almost all the way back around to 2 pi. Quadrant 4. 5 pi over 6. 5 pi over 6 is in quadrant 3 or 4.
3. 3.
I think it's 4. Because 3 pi over 2, if I converted this into a common denominator, I'd get, let's see, let's just even look at it this way. Let's multiply by 180 over pi. Pi's cancel. 6 goes into 180 30 times. 5 times 30 is 150. Where's 150 at? Oh.
2.
It's in quadrant 2, huh? We were way off base. Jeez. Negative pi thirds is negative 60 degrees, so it's down there, so that's in quadrant 4. And then 5 pi over 4. 5 pi over 4. So it's bigger than pi, smaller than 2 pi, so it's either 3 or 4. What do you think?
3.
3? I think so too. And again, if you just kind of manipulate, saying if I multiply that by 180 over pi, I get 45 times 5. That works. Am I done?
2 more slides.
Oh. Since we are focusing on the angles from the unit circle, only the reference angles that exist in radians are, okay. Find the reference angles. Okay. All right, so we want to base this off the x-axis. So 5 pi over 4, is that bigger than 1 pi? Yeah, so it's going to happen in quadrant 3. So this is happening in quadrant 3. So let's figure out what the reference angle for it would be. Remember, the reference angle is one of the acute angles. So it's either a 30-degree angle, a 45-degree angle, or a 60. But we want to make sure that our angles, so a 30-degree angle was pi over 6. A 45-degree angle was pi over 4. And a 60-degree angle was What?
Pi over 3. Pi over 3.
Thought I had done it.
On that big circle.
Where's the big circle at?
Side.
Pi over 3, good. Alright, so that's what our angles need to be. So 5 pi over 4 is in unit, it is in quadrant 3. So think about where that's at, that's down here. So if I subtract that 180 away from it, or my pi away from that, so if I subtract pi from it, that's going to just give me pi over 4 as my reference. So pi over 4 is a 45-degree angle, meaning it's going to relate to the 45-90 right triangle in quadrant 3. The legs of the 45-90 in quadrant 3 are both negative. So that's going to mean something, so note that. So 4 pi over 3, that's larger than pi. So that also is going to happen in quadrant 3. So I'm going to go 4 pi over 3 minus pi. So that'll make that 3 over 3 pi. So that gives me pi thirds. So that's talking about a 60-degree angle in quadrant 3 as well. And again, in quadrant 3, both my x and y components, both my legs of my triangle are going to be negative. Guys and girls, I'm going to say that the legs will always can be positive or negative. The hypotenuse will always be positive. Okay? 11 pi over 6.
Quadrant 4?
Quadrant 4, I like it. Did it go around twice or once?
Once.
Or did it go all the way around?
It's 30 degrees.
So close to the
Yeah. So I'm going to subtract, I'm going to go 2 pi, because 2 pi is all the way around, minus 11 pi over 6. Okay, so that's 12 pi over 6. Minus 11 pi over 6 gives me just pi over 6. So that happens to be a 30-degree angle in quadrant 4. Okay? Wow, almost done. And last one. Convert the measures. Each of the 16 angles has 2 ways to give it. Okay, so we want to, right? Converting angle measurement. Use the unit circle. Each of the 16 angles have 2 different ways to give the measurement. Use the unit conversions. Okay. So this is going to be pi over 6. It's going to be pi. What's 135? That's a 45-degree angle over there. So that's pi over 2 plus pi over 4. So that's going to be 3 pi over 4. Pi fourths. We want to put it into a degree amount. So I'm going to multiply that by 180 over pi. Cancel, cancel. 4 goes into 180 45 times. 2 pi over 3. So multiply that by 180 over pi. The pi's cancel. 3 goes into 180. That goes into 180 60 times. Times 2 is 120. And then 7 pi over 6. Again, I'm going to multiply by 180 over pi. Those cancel. That's 30. So that's 210 degrees. Is that it?
Yeah.
Dude. All right. So some of these things should have you going, huh? Trig worksheet C. You're fine doing them all. So question for you, ladies and gentlemen, question for you. I will tell you, I am happy to print this up for you and create this for you if you would like it. The faster you can start identifying the degree to a radian and from a radian to the degree, the better it will be for you. Does anybody want a set of flashcards?
Yes.
I will print it up for you. It's your responsibility to cut them out.
Okay, sounds good.
Cool.
That's fine. What do we have to cut?
I'll create a flashcard thing for you of like, so you can go 30 degrees, that's pi over 6. Pi over 6 is 30 degrees, so I'll create flashcards for you. Good? But you guys have to cut them out. And it won't be on, maybe I can put it, I'll put it on cardstock too. Put it on cardstock, and then you have to cut it.
All of a sudden,
Let's have a craft stay.
to be
Craft
Craft
stay.
stay.
We'll bedazzle it, it'll be awesome.
just got into class, all of a sudden
Color
Yep.
Color pencils and all that.